Hi everyone, this is going to be your pre-lab lecture for Lab 7, Understanding Polarimetry. As always, make sure you guys read your lab manual from the PDF file provided. Make sure you watch these videos. Personally, I really like this one and this one. It's the two videos that I got the most information out of. Make sure you do your pre-lab notebook. Time yourself with your notebook. Another thing I wanted to bring up, make sure you guys, if you guys are going to email me with questions, and they're very important, make sure it is 24 hours before the deadline. I've been getting emails about 2 hours before turning in the notebooks. So I might get to some people, but I might not be able to get to other people. So just in case you guys really want those questions answered, please message me 24 hours before. Your pre-lab quiz, that is going to be due before everyone's set in the morning, like always. Group B is going to be doing this lab for the week of October 26th to the 30th. And then Group A is going to be doing this for the week of November 2nd. Your post-lab notebook, like I said, make sure you time yourself with it and turn it in on time. It is due before every Sunday at 11:59. This is the data that's going to be used depending on your first name. We can take a look at it afterwards, but first I want to show you guys the PowerPoint and the presentation. Okay, understanding polarimetry. What is a polarimeter? It's a device that measures the rotation of linearly polarized light by an optically active sample. And it basically enables the differentiation between optically active stereoisomers, for example, enantiomers. Enantiomers are just chiral molecules which lack an internal place of symmetry and have a non-superimposable mirror image. And basically, one way to tell between these two enantiomers, for example, these two on the screen, would be using polarimetry. It is helpful for biological applications because amino acids, nucleic acids, carbohydrates, and lipids are optically active. And for our lab, we're going to be using sucrose and fructose, I believe. So that is also part of our macromolecules. The determination of the optically active activity of a compound using polarimetry allows the user to determine various characteristics, including the identity. Like I said, for example, if we have fructose, galactose, they have very similar structures, and we can differentiate between the two using polarimetry. To determine various characteristics, including the identity of the specific chemical compound being investigated. The process. Okay, so this is basically what is going on right here. And you guys are going to see in all the videos, they're going to explain this. Incident non-polarized light is transmitted through a fixed polarizer that only allows a certain orientation of light into the sample. The sample then rotates the light at a unique angle. So every single sample is going to have a unique sample, and that also helps to determine what chemical we're working with. As the analyzer is turned, the rotated light is maximally transmitted at the unique angle, allowing the user to determine properties of the sample. So if you have a positive enantiomer, it will rotate the plane of linearly polarized light clockwise. And that movement of being clockwise is also known as dextro. I'm actually not sure if I'm pronouncing that correctly. I don't know, but it's in a different language. And then a negative enantiomer rotates the plane counterclockwise. Libo, sorry, if I'm pronouncing it wrong, you can correct me. Now, I believe this is Biles law because it's French, but I'm not too sure either. And basically, it's a law that says that a compound will constantly have the same specific rotation under identical experimental conditions. To determine the specific rotation of the sample, we use Biles law, where right here, our observed rotation is the observed optical rotation in units of degrees. And then we're going to have our specific rotation right here. And in your lab manual, this equation is given a little bit differently, but this is just the manipulated version of that equation. And this equation right here, the one that's in the PowerPoint, is the one that's going to help you for your post-lab questions. And I feel like this is labeled very accurately, and it's going to, the labels in the equation are going to help you guys differentiate between everything. Yeah. Okay, the objectives for this lab. You have to become familiar with the use of polarimeter, experience how sample path length and concentration affect the observed rotation, and calculate the specific rotation for a known sugar sample using Biot's law. This sugar sample is going to be a sucrose solution. For your pre-lab calculations, make sure you include the layout of Biot's law, and then make sure you put angle of rotation is equal to angle sample minus the angle blank. And that's all you need for your pre-lab calculations. You don't need to solve anything. You just need to put this outline. For data and analysis, you will fill the two tables provided. So for part 1, it says exploring path length, and then for part 2, it says exploring concentration, and you must show work. I will talk a little bit more about the tables after the presentation. I just want you guys to have sort of like information about what you should be doing, but I will talk a little bit more about it. Changes, no changes. Okay, so this is the second part of your lab, and it's called using polarimetry to identify an unknown. And if you guys scroll down on the PDF file, you guys will find this part too. So the objectives for this one are to calculate the specific rotation for known sugar samples using Biot's law. We have glucose, galactose, fructose, and sucrose, and we will determine the identity or unknown samples based on specific rotation. Basically, we're going to be getting a specific rotation, and then we're going to determine, okay, is it glucose, galactose, fructose, or sucrose? Sorry. For your calculations, this also has two parts to it, two tables. So you will fill out part 1, which is the determination of your standards. And from those standards, since you already determined what they are, that's going to help you determine what your unknowns will be. So use the determination of standards, the table, to identify the unknowns for part 2, which is identification of unknowns. Reminders. Really quickly, I just want to say about your post-lab questions. I've been getting a lot of notebooks for your post-lab questions are before your conclusion. Your post-lab questions go after your conclusion. Please, please, please put them after your conclusion because this is a wrong order and points can get deducted for this. Also, at the end, I'm going to mention a little bit about the extra credit just to make sure that everybody is going to do it. And then make sure to turn in quiz and lab reports on time. Your participation points depend on you turning everything in on time. So please make sure you guys do that. Okay, so let's open up your data. Okay, I'll just do it through here. Okay, I'm just gonna open a random one. Okay, these two tables are for your first part of the experiment, which is understanding polarimetry. And then these two tables are for your second part of the experiment, which is using polarimetry to identify an unknown. Now, when I said filling your tables, you also have to show in your work. So for example, right here where it says angle of rotation, angle sample minus angle blank, you need to show that you're subtracting this by this separately. So what I would do is do your two tables. Right below your two tables, do all the math for those two tables for that section. And then go ahead and do this part, do your tables, and then do your math for this whole section. This whole section definitely has more math, so you definitely need to include math for this section, no matter what. This part, it's easier math, but you still need to include it. So given that it is two labs in one, two sections in one lab, your purpose also needs to have both objectives combined for part 1 and for part 2. Now, I've been getting a lot of purposes that just list the objectives, and that's not what you're supposed to be doing. You're supposed to be putting in your purpose the objectives, what is the purpose of it, what is the theory behind the experiment. You're supposed to be putting how scientists use polarimetry. You're supposed to include all of that in your purpose. And then in your conclusion, you're supposed to discuss why did you get these results? Was there an error in your results? Were your errors high? Were your results high? Were they low? you guys need to describe all of this in your conclusion. And that is all. Actually, let me talk about um, let me talk about the extra credit. Okay, so the extra credit is worth 15 points. So it's divided between 10 and 5. So if you complete the discussion, you will get 5 extra points. If you complete the poster board with an experiment that could be done at home, that will be 10 additional points. So that is some easy points to pick up your grade. I say do them. Um, I believe he said he was going to send probably like an email saying that um, that it was going to turn into mandatory. But please do them. They're easy points, and it's going to bump your grade a lot. So yeah, those were all the announcements I have. And yeah, if you guys have any questions, please email me. Bye.